Okay. So the total loss of permanent serviceability is in AASHTO, if there is swelling problem or frost heave problem, that needs to be added here. So because delta PSI, because of traffic, is not sufficient, and there's a procedure that in the AASHTO 93 design guide to how to calculate delta PSI because of swelling. And here you use the plasticity index. If there is highly plastic subgrade soils, you have to come up with a correction factor for delta PSI. And also delta PSI, because of frost heave, there's another correction factor you have to do in AASHTO 93 design. What is PSI? PSI is the serviceability index, and typically condition is calculated from here. This is an empirical equation. SV, you can see this mean of the slope of variation of two wheel paths, and C is like measures of cracking and patching in the pavement surface, C and P, depending on cracking and patching. That this is the equation used to calculate the serviceability. This is again from AASHTO road tests, and depending on how much patches and cracks they've done there. So typical problems. This really comes mostly from my experience as a pavement design auditor. That I've done this quite some time. So typical problems that you want to avoid. No or limited traffic count. So the designers that I've experienced with, they don't like to do traffic count. Even though they have the money, they have the means and all that, it's easier not to just sit in front of your desk and try to figure out. So traffic count is extremely important for any pavement design. Growth rate of the traffic, arbitrarily selected. Okay, let's just assume 1%, 2%. Well, growth rate could be negative. You might have population reducing for that location. So it's not always more than zero. There are traffic estimation models, but they're incorrectly used depending on the location. Truck damage effect is arbitrarily considered. Truck factor, this was also very, very common. If you have data, like WIM data, truck factor, you need to estimate, you have to calculate that based on WIM data. Geotechnical investigation, limited or no geotechnical investigation done in roads. This is one of the common problems. And incorrect interpretation of the roads is also, incorrect interpretation of the geotech data is also like that. As I said, I talked to you about the example, right? You have a geotechnical investigation report on page 900, and incorrect interpretation of that is we don't have one. So it's no. In another report, the same designer, he has done, okay, I've looked at the geotechnical investigation report, and that includes a whole bunch of CBR values, but I chose 15% because the data shows 15%. And when I looked at the geotechnical investigation report, this was like a 10-mile road. There were boreholes collected every 1 kilometer or so. And along a whole road, there was like 2 boreholes that showed CBR of 15 or less, only 2 of them out of 15 different boreholes. And those were only confined into a certain location. Obviously, the designer was really trying to increase the layer thickness because that's the designer was being paid based on. So the higher the layer thickness, the more the money the designer would get. It's not in this country, by the way. So it's in a different country. So, it's just, that was convenient. So anyway, so also important material properties are ignored, and like viscoelasticity of the material asphalt layer, and very outdated, incorrect models used. What do I mean by important material properties? One of the things is there are fundamental issues in that. Remember yesterday we talked about the layer coefficient versus climate. See, 0.44, layer coefficient of 0.44, typically used for asphalt layer, there's a reason for that 0.44. It can go up and down depending on, the type of material. If you have a polymer modified material that you are using a little bit better material, maybe it will go up. But you cannot change that layer coefficient because you are a different climate. Like for example, in Michigan, okay, let's use 0.44, but I'm in Florida or Hawaii, the weather is very hot. Well, you told us, Dr. Kudai's layer coefficient is based on stiffness. Well, that's a hot region, let me use a lower layer coefficient to be on the safe side. No, that's incorrect. Why? Because in Hawaii or Florida, we are using a different PG, performance grade material. We use a stiffer material to meet that modulus. Remember yesterday what we talked about? Whether you design a pavement or material in Michigan or Florida, the stiffness is the same. Your material stiffness is supposed to be more or less the same because you're using different PG, performance grade, a stiffer material in hot climate and softer material in warmer climates. So material design, super pave mix designers, they did it on purpose. So we need to be knowledgeable about what super pave design is and what material design is and what pavement design is. Lastly, before our break, the vehicle speed, temperature, load level, these are all ignored. These are not mandatory, but we need to talk about the stiffness of asphalt and how it changes with vehicle speed. And all those we're going to talk about in the next session. So that is the end of the session.